So now with this video, we're going to calculate our deflection, and there's two different deflections we're going to calculate. The first one is the allowed deflection. So I want you to write down all these definitions right here of what we have. So the first thing is, remember that our live load plus dead load, when we did the calculation for that, we ended up with 1,000 pounds per linear foot. So our uniform load is going to be 1,000 pounds per linear foot. L is the length of the beam, which we know is 18 feet. The modulus of elasticity for steel, that is a given value. We'll look at that in a few minutes when we go through that. Actually, it's 29 million, just so you know what it is. And then I is the resistance of material to bending, and that's going to come from our chart. So the formula we're going to use here is the delta DL, dead load plus live load, equals the length, that should be L, over 240. So we're going to take and do this calculation. So we're going to get the delta dead load plus live load is going to be equal to 18 feet, and that has to be converted to inches, so that is going to be 12 inches over 1 foot, and that's going to be divided by 240. Now, when I do this calculation and go all the way to the end, I get 0.9 inches, because the feet cancel here, so I'm left with inches. So our delta for the dead load and live load is going to be equal to 0.9 inches. Okay, so that's the deflection limits for the allowed. Seventh step, we're going to calculate the actual deflection. Now, the actual deflection is called delta max, and that is equal to 5 times the uniform load times the length raised to the 4th power divided by 384 times the modulus of elasticity for steel, which is 29 million, you'll see that in a couple of minutes, times I. And I is a value that we're going to get from the chart. So we're going to start putting in numbers here. W max is equal to 5 times the distributed load, which is 1,000 pounds per foot. And because this is in feet, we have to convert that to inches, which is going to be 1 foot over 12 inches. Actually, I probably shouldn't have put that right there. This is going to be a multiple. Okay. Times the L, which is 18. Again, this is in feet, so this has to be multiplied times 12 inches divided by 1 foot, and that gets raised to the 4th power. So let's do some cancellation of units here. Pound feet, this cancels with this. This guy over here cancels. So we end up with inches squared. Yes, we do. Okay, now this gets divided by, and this is going to be by the 384 times 29 million, and that is pounds per inch squared, times the I value. Now the I value, we have to go to the chart and look it up on the chart. So I'm going to find my chart. Here we go. I'm going to go to properties, and I'm going to go down. I'm going to go all the way down here rather than scrolling through this. I know this is way down at the bottom, and I'm looking for my W12 by 14. So W12 by 14, W10, W12 by 14 is right here, and our I value right there, that's I, is 88.6. Come on, you. I'll get this down here. There we go. I'll leave it highlighted. So 88.6. So Alt Tab. So I'm going to put in 88.6, and those are inches cube, well, raised to the fourth. Now, lots of cancellation stuff has to go on here. This is going to be, when we multiply this times the 12 inches here, that's going to give us inches cubed. Those will cancel out. So we're not going to do that though, because we do have to raise this times to the power of the fourth. Okay, so let's see. I understood what I said there. I hope you did too. We're just going to leave it alone right now. We'll cancel it at the end. All right, so I'm going to turn this on. Now I'm going to multiply 18 times 4, and I'm going to raise that value to the fourth power. So 18 feet times 12 inches equals 216, and I'm going to hit my raise to button here, 4, and that gives me that number. Now I'm going to multiply that times, there might be a better way of doing this, 1,000 times 12. I think I got this wrong. Hold on a second. I'm going to do this calculation again, and then I'll come back to you. Found out where my mistake was. This is 1,000 pounds, and it's going to be divided by 12. So I'm going to do that first, actually. So I'm going to take 1,000, divide that by 12, and I'm going to get 83.33. So I'm just going to write that right here, 83.33, and that's a repeating number. Okay, so cancel that. Now I'm going to take my 18 times 12 equals, I'm going to raise that to the fourth, that equals that value right there, which is a very big number. I'm going to multiply that times 83.33 equals times 5 equals, and I get a value of 906,956 blah 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 to the 11th. Now what I'm going to do is I'm going to start dividing this. Now I can calculate all of this out, or I can just take it as individual pieces. So I'm going to take this number, I'm going to divide it by the 384. 384 equals, divide it again by 29 million equals, divide it by the 88.6 equals, and I get 9.19 equals 9.1. Oh, I'm sorry, doesn't equal 9 point, it equals 0.919 inches. So when we cancel everything out here, we get 0.919 inches. Now the problem is that that is greater than this 0.9. So our this is the delta max that we just calculated. So our delta max is greater than the delta allowed, and that means that our W12 by 14 beam is not allowed. And you are probably going to be starting to think to yourself, we just went through all this work and now we're going to have to choose a different beam and do all these calculations again. But you are not correct about that. We don't have to choose a different beam. Well, we're going to choose a different beam, but we don't have to do all these calculations because we're going to set up a ratio. So I'm going to go Alt Tab. I'm going to go back to my chart thing here, and I'm going to go in properties here. I'm down here with my W12 by 14. The next one up is a W12 by 16, and this has the I value of 103. So we're going to use the W12 by 16, and its I value is equal to 103. Now, we don't have to redo all this calculation stuff because we're going to do a ratio. So I'm going to set that up right now. And the ratio is going to be the I current value. And that's going to get divided by the I new value. Okay. So that is going to be the 88.6 is the current, divided by the new, which is 103. And if I take that, so I take 88.6, whoops, I'll bring this back to you, 88.6, I'm going to divide that by 103. That gives me 0.86 equals 0.86. So the W12 by 16 beam is going to be less than that 0.9 inches. So that is a good beam. Because this value right here is 0.86, and that is less than 0.9 inches. And this one should be inches down here also. So that's how you do that calculation.